Hello, this is Dr. Himayatullah, and today I am going to discuss how can we check unit root test in a time series data. So I am basically using augmented Dickey Fuller test, and let me open my data file. This is time series file in which I have a number of variables. CPI is consumer price index, IP is industrial production, M1 is supply of money, T bill is a treasury bill for 1 year. So I'll be checking unit root for variables one by one. So first I would like to check for consumer price index. So the first step is to write what is my null hypothesis. So my null hypothesis is that CPI has a unit root. Alternatively, I can say that it is a non-stationary series, and I'll test this null hypothesis against the alternative hypothesis, which is that CPI has no unit root or it is stationary. So before using the formal augmented Dickey Fuller test, I'll first open my variable, that is CPI, and if I double click it, the data is generated here, and these are the monthly data from 1969 January up to say this is 2011 December. So there are a large number of observations in this file. Uh, my first step would be to view the line graph of this series. So I would go to view, I will press this and then graph, and after this I'll press OK, and I'll get this graph of CPI. Now if you look at this graph of CPI, now this has an upward trend. You know, the consumer price index is trending upward over time, and I also observe that there is also an intercept here, a positive intercept here. So it seems that this data would be non-stationary. It has both intercept term as well as the trend. Um, if it were a stationary series, then the consumer price index data would have evolved around zero mean. But obviously, CPI is not evolving around zero mean. So I suspect that CPI is not stationary. So I'm going to use augmented Dickey Fuller test, and I'm testing the null hypothesis that consumer price index has a unit root. It is not stationary. So how can I do that? Let me view and go to unit root, and after going unit root I get this dialog box, and under this dialog box the level is checked, and here intercept is checked. Now by observing the graph, the line graph of the CPI, I observed that there was the intercept as well as the trend. So I would click this one, and these are the various criteria. There is Schwarz information criteria, Akaike information criteria, Hanan-Pin criterion, modified Akaike, modified Schwarz, and so on. So I would leave this Schwarz, and these are the maximum lengths by default. So I will leave this here, and now I will press OK. When I press OK, so I get these results. Now before I give any decision on this, look at this null hypothesis, and it is that CPI has a unit root. Now come to the model here, and in this model you see that the augmented Dickey Fuller test has regressed. The first difference of CPI on lag value of CPI, then the first difference of the CPI in the lag term, and the second, and this is the constant, and this is the trend. Now if you look at the constant term, the coefficient is equal to 0.098. This is its standard error, this is its t-statistic, and its p-value shows that it is highly significant. Similarly, the trend term also shows that this is statistically significant. So I have made the right choice, that I have used both the constant term as well as the intercept term. So now let me also look at the Durbin-Watson. Durbin-Watson is um, almost 2. So now now let me see the T statistic. Now the T statistic of augmented decoupled test is 3.814665, and if I compare this with these values, that the test critical values which are provided by decoupler, now this value in absolute is less than this value. So I fail to reject this. So it shows that the consumer price index has a unit root. Now I will check this again, and I will take the first difference. So unit root again. This time I will check first difference, and I will check with the trend and intercept. But let me start. Yeah. So okay, and after okay, you see again that in the model both the constant term as well as the trend term are both statistically significant. So this model should have both the constant as well as the trend term. And now if I compare the ADF test statistic, that is minus 14.32611, with the test critical values at 1%, which is minus 3.97, and at 5 level it is minus 3.417, and at 10% level it is minus 3.130911. And this test value is in absolute greater than all these, and you can also verify the same from this. So we now reject the null hypothesis, and we conclude that the series of CPI in its first difference is stationary. So we have now converted a non-stationary series CPI into a stationary series by taking the first difference. This is how you can do the augmented decoupled test for converting non-stationary data into stationary data. Now let me also compare the other results. So go to view again, and unit root, and this time let me only use intercept. So if I only use intercept and press OK, so my results are again C is so the constant term is significant, and this shows that the null hypothesis is rejected at the first. So now going to the third alternative, and that is none. So this time if I see when I did not include both the constant and the intercept, now this time my results are not trustworthy, because the augmented decoupled test statistics is now lower than even test critical value at a 5%. So it means that I have not made the right choice. So the right choice would be that by observing the graph of the CPI, I observed that it has a constant as well as the as well as the trend. So I must also use both the trend and intercept term at the first difference. And if I do that, I get my results again. And my augmented decoupled test statistics of minus 14.32 is higher than these critical values, and on the basis of its p-value, now I can safely reject the null hypothesis that DCPI has a unit root. So I will conclude that the first difference of CPI is now stationary. Thank you very much for watching this video.